Okay, in this video we're going to talk about independent events and also cross-tabulation tables or contingency tables. And two events are independent if the conditional probability of the first one given the second one is the same as the marginal probability of the first one. And what this really means is that it doesn't matter whether B happens or not, the probability of A stays the same. So in that previous example where we looked at the probability of being unemployed given that you dropped out of high school, we had 18.31%. If we compare that to the probability of being unemployed, 13.5%, we see that since those things are not equal to each other, U and D are dependent or not independent events. And that makes sense because you might say, well, what's the probability that you're unemployed? And the question then can be answered by, or better answered by asking, well, did you drop out of high school or did you finish high school? And since those probabilities are different for high school dropouts, then that means they're dependent. Another way to check this is by using the law of multiplication, which says the probability of the intersection of two events is equal to the product of the probability of the events. And this is because if we look at the probability of the conditional probability of A given B, that's just the probability of the intersection divided by the probability of B. Right? So this is what we already talked about. And so if they're independent, we're saying this is the case. We can substitute that in here and the B's cancel out and we're just left with the probability of A. If we have more than two events, we can do the same basic idea. Probability of the intersection of all the events is just equal to the product of the probabilities, and that's true if they're independent. So oftentimes instead of checking that, we're going to make the assumption that they're independent and go ahead and use this result. And this actually turns out to be used quite extensively in statistics. A good way to illustrate that is by looking at a website that has two independent file servers, and each server is 99% reliable. So the question then is, what's the probability that the total system is going to be running, or rather what's the reliability of the system? And so we're going to answer that by using the events F1 and F2, which says that file server 1 fails or file server 2 fails. So using independence, we can say what's the probability that they both fail, and that's just 0.01 times 0.01, which is 0.0001. So that's the probability that both servers are down, and that's going to be the complement of the whole system working. So if we want to know the probability both servers are up, we just take 1 minus that, so 99.99% reliability for that website. This brings us to contingency tables. A contingency table is basically just a table that tells us values associated with more than, well, in this case, two different variables. So here we've got, for 67 top-tier MBA programs, we've got salary gain. So how much do you improve your salary by going to their program over the 2 years or whatever it is, and the tuition. So we've got small gain, medium gain, large gain, and then counts for each of these things. If you sum down the rows, if you have the column sums, you're going to see 17 out of the 67 are small gains, 33 are medium gains, 17 are large gains. Sum across the columns for the row totals to get 16 are low tuition, 19 medium tuition, and 32 are high tuition. And the cross-tabulation table or contingency table gives us a breakdown of how these individual intersections come out. So we'd say there's 5 that are small s and low t. There's 1 that's large s and low t, and so forth. So looking at the cross-tabulation table, we can get a good idea of what's going on. The higher the tuition, the larger the salary gains tend to be. Most of the top tier schools charge high tuition. We can see that. So what does it mean, most and tend to have and so forth? Those are questions that can be better answered using probability, and a cross-tabulation table is something that is set up perfectly to do that sort of thing. So first of all, we're going to talk about the marginal probability for each of these variables, and that's found just by dividing the row or the column total by the sample size. So for example, if we want to know the marginal probability of a medium salary gain S2, all we have to do is come back up here and look at this and say S2 has 33, so 33 out of the 67 are medium salary increase, so that's about 49%. So we can conclude about 49% have top tier schools have an increase in salary between $50,000 and $100,000. And again, we can see that here by taking 33 divided by 67, and that's how we get the probabilities associated with this cross-tabulation or contingency table. Joint probability is something that is the probability of the intersection of two events, and each cell in a cross-tabulation table represents a joint probability or an intersection. So for example, if we wanted to know probability of T1 and S3, that's a low tuition and high salary gains, all we'd have to do is go in and say how many of those are there? There's just one divided by the total number, 67. That gives us less than 2% probability for that intersection. So if you want to get a higher salary, maybe going to a low tuition school is not the easiest way to do that. Not that it can't be done, just a low chance of that happening. But there are other reasons why that might be, and without having more information we couldn't say for sure. But imagine if you went to somewhere that charges a lot in tuition, it's going to cost you a lot more. You're going to maybe have to do student loans, and that's going to force you to take a job that pays higher. And maybe you want a job that pays higher, maybe you don't want a job that pays higher. That's not necessarily the only consideration that you would take into account. Location, benefits, working hours, conditions, those sorts of things would also come into account. But so there's lots of reasons why there might be a high correlation between tuition and salary gains. If we want to find a conditional probability of a small gain given a large tuition school, we can find that by taking probability of S1 given T3. So we're given, so we want the probability of a small given large T3. So that's just going to be 5 divided by 32. Come back and look at this again. We've got 32 here in the high tuition. 5 of those are small, so 5 divided by 32. If we wanted to check independence of some of this stuff, we can look at the conditional probability of S3, so a high gain school given a low tuition cost, and there's only one of those that one high gain school given a low cost. So come back and look here. So that's going to be this one, and then we're going to divide that by the row total of 16, so 1 over 16. That's about 6%. What's the marginal probability of S3, a high gain at 17 out of 67, which is about 25%. So these two things are not equal to each other, which means that they are dependent events, and subsequently that means that they are both of these random variables are dependent as well. Relative frequencies, that's just another way of saying probabilities or estimates of probabilities, and we get those by dividing everything in the table by the sample size, so 67. So if we want to know the probability of the intersection of T1 and S1, That's going to be 5 divided by 67. That's that number right there. T2 and S2, that number. T3 and S3, that number. If we want to know a marginal probability, it's the probability of S1. That's going to be that number. Marginal probability of T2 is going to be that number. So that's contingency tables and independence, and very useful tools. We will have another video coming up shortly with tree diagrams, Bayes' theorem, and then something about counting as well. So we'll see you in the next video.